In this demonstration, I'm going to work through the first two tasks in the FinTute exercise. Now, these are really intended for people that have absolutely no background in either Excel or the kind of relationships that you find in working with business calculations, and especially the kind of profit and loss calculations. So the first task basically introduces you to the way that Excel equations work, and also gets you to think about very simple concepts in leverage. I'll also go through task 2, which is primarily to give you a demonstration of how the table function works in Excel. This is a really easy function which is extremely powerful and very, very useful when you're doing reports based on DCF analysis. And so because it's an easy tool which is very powerful, definitely worth knowing, but it can be a little bit mysterious to work it out. Now, while I'm going to do this demonstration, I don't really want you to use this as the first way of learning how to do it. I would really prefer for you to try and complete these tasks yourself, following the instructions that are on the FinTute page. And so you'll notice that as well as the basic question, there's also a number of hints, typically in brown font. Also, with this exercise, it introduces you to the self-correcting strategy which is built into these exercises. And so you'll notice that your answers, the work you have to do in the spreadsheet, is all in cells which currently have a yellow highlight. They self-correct because they have the highlight that goes away once you put in the correct answer, which is usually an equation. And so in this way you can work through and see your work basically corrected or graded as you go along, because every time you get rid of a yellow highlight, it's telling you that you've done the right thing. Let's go into these tasks now. I hope that you at least tried to complete task 1 before watching this demonstration video. But what I'll do now is work through the solution. You'll notice that we have a panel here which is full of yellow highlights, and so this is where we're going to be doing our model, writing our model. The first yellow highlight we have to get rid of is here for the value of the net rent. That's extremely easy. It's simply a matter of importing the net rent from our data over here to the left. And that's a very nice, easy equation. All Excel equations begin with an equal sign. In this case, we're going to say this cell is going to be equal to the value that we find in D7. That couldn't be easier, but it demonstrates how Excel equations work. You'll notice the yellow highlight has disappeared. The second equation is going to be a bit more complicated, because we're going to now have to work out what the interest payment is. The interest is worked out by, first of all, working out how much principal is on the loan, and then multiplying it by the interest rate. Let's see how we go there. We begin with an equal sign as before. Now we have the percentage of debt as leverage, and that's 60%. The property value is $100,000, and so we can work it out as $100,000 multiplied by, which is the star, which is shift 8, by 60%. That gives us the value of the principal. We're working with an interest-only loan, so working out the interest on interest-only loan is really easy, because you simply multiply the principal by the interest rate. And we'll do that, another star, the interest rate 6%. There we are. Couldn't be easier. The pre-tax profit now is going to be the net rent less the interest. So we're going to take from the $10,000, $3,600, until we have $6,400. You'll notice the yellow highlights keep disappearing. Have to work out the tax. Tax is worked out as a percentage, in this case 40%, multiplied by the pre-tax profit. That gives us 2,560 with this current data. And we simply subtract the tax from the pre-tax profit another very simple equation to give us the net profit. The equity takes a little tiny bit of thinking about, but it's simply what's left after we use our borrowed money. And so for the property value of $100,000, the equity is equal to the property value multiplied by 1 minus the leverage, 1 minus 60%, or D8. You'll notice that I'm using cell addresses rather than numbers for my equations, and the reason for that is that it allows my model, what I'm building here, not simply to answer the question as it's set with the data that I've given, but also to be able to adjust as the data is varied. And so I've got a dynamic model, a model which is able to respond to changes in the data. You'll also notice I use a convention here, which is blue fonts for data, black fonts for calculations and answers. You'll find that that's the same color convention that Estate Master uses for their various models, and it's common across the industry because Estate Master is so common in Australia. We're simply using it here, and it does make life a lot easier. I can see what numbers I can change as well as what effects they're going to have. Now I get down to the return on equity. Now return on equity is simply the ratio of the net profit after tax divided by the actual equity. Nice easy equation, $3,840 divided by $40,000 here. And so that's the end of task 1. The nice thing about this nice simple leverage model is that the way that we've done it, we can change the data. Here I'll take my leverage to 80%, and you'll notice that the model changes. I'll put it back to the original data now. Generally, I'd recommend that whenever you do models, you write them in this way so that you can have differences in the data, because you'll find that very useful. Okay, let's imagine we've got this as our model. It's a fairly simple financial model, but it's still quite a useful one. Leverage is extraordinarily powerful. But then I might want to see what happens as I change the values of these input parameters. I can use the table function for that, which is what I have in task 2. Task 2, it's asking us to develop a table from the model developed in task 1 that shows the return on equity versus the percentage of debt and the interest. Now, the way I do that is by building this table down here. Now, I've already formatted the table, so that lays out basically what's going to happen. The actual table itself, we can exclude the headings, and so you'll notice that there's various values of the leverage across here, and so I'm looking at 0%, 20%, I'll do 40, 60, 80% across here. Now I could just write in these numbers. I could write 40% in, and that's fine, and it will make the yellow highlight go away. Or I could use the fill function, which is inside Excel, to automatically do that. And so you'll notice that just by grabbing that little grab handle on the bottom right hand corner and then pulling it across, Excel automatically increments that value. One thing that it doesn't do, and I'll just get you to notice here, is that the formatting can be mucked up because it's also copying the formatting. So you'll notice there's a little bit of border that's been messed up here. Here we'll attend to the formatting after we've got the table layout generally set up. Because what we want to do now is we'll just take the same approach and apply it to the interest rate values, and here we're going to fill it down so we've got 2% increments going all the way down. We'll grab all of that area, go into the border menu box, and we'll simply put that border back around so that's all fine. Now we get to the real table function. The table function in Excel has a particular way of doing things. For a two-dimensional table, in other words, you've got 2 dimensions, 2 variables which are being considered. The way that you lay out the table is quite critical. You have the values for one variable as a column of values. Here we have 2% to 20%, and then a row of values for the second variable. Here 20% increments up to 80% for the leverage. You'll notice they're laid out so that there is one cell that's kind of the corner, the intersection of that row and that column. Now in this row we put the equation which the table is going to evaluate. We could put an equation which is simply built on those two values. We could add them together or something. In fact, we might do that just to demonstrate. We'll say it's going to have the interest rate, which we'll put maybe there, and the leverage rate, which we'll put there, and we'll add them together. Let's do that. That plus that, whatever. Okay, there's no numbers in there just yet, so what I'll do, I'll just put a value. I'll put 6%, and I'll put 10%. You'll notice that my equation is now 16%, which is what you'd expect. I'm going to use this just to demonstrate how the table works. To set up the table, I select the equation and all of the rows and columns of the values of the variables. So I point, click and drag to select all of that. Then I go into the data menu. I go across to the what if analysis, come down to data table, and a small window will appear. Here I need to put in the cell where the row of input values is going to be input. Now in the little equation that I've done, it just happens to be this position there. Likewise, I need to input where the column of input values is. These are the column input values, and they want to go over there. Let me fix that up. Come down here. The column input cell is hit go. And if you look closely at this, what you will see is that each of these, say the 24% here, is a combination of the 20% from above added to the 4% here. If we go down to here, we see that the 78% is a combination of the 60% from there added to the 18%. So what's happening is that the content of each one of these cells in the body of the table is the answer to the equation, which is up here in the corner, worked out for the values of the variables in the respective row and column. That's the way that table works. Now, that's a fairly trite example, but it gives you the idea of how it works. What I'm going to do is just take that out, and we're going to now use a different equation. I'll take all of that stuff out, and we use delete. By the way, if you try to delete a part of this body of the table, you'll find that Excel won't let you do it. You have to delete the entire contents of what table puts in. Okay, now I want to find out what the return on equity is for these different combinations of interest and leverage. Return on equity is found in the model I did in task 1. So here the equation is actually quite simple. It simply equals return on equity. Up here it's 9.6% from the little model I did in task 1. There you are. So that gives me 10% in this case. Now I want to do the same thing. I'm going to set up a table by selecting the entire area of the larger table. That includes the column of values, the row of values, the equation, and then the body of the table. I go into the data menu, go across to what if analysis, select data table. Here, the row input cell, the row of input values, is the leverage. So I want to come up to my model, which is task 1, find the leverage cell. In this case it's D8. Put that in. The column of values relates to the interest rates. So I find the interest rate input cell, which is D9. And so I have the row of leverages values going into D8, the column of interest rate values going into D9, and let's look at the different combinations. Come back down to my table here, and what I see is that now I have this range of different returns on equity depending on the different combinations. If you look closely, you can check this by checking that the interest rate, which is 6%, and the 60% of debt leverage is in my table, it's down about there. And so you'll notice that 10% return on equity in my model, the static calculation, is also there, and so on. So it's a way of checking. Now this table function is extraordinarily valuable because what it means is my model can be now checked, analysed for different combinations of possible interest rates, which is one of the things I can't control in the environment. The Reserve Bank will change the interest rates on me, or my local financier will, so I'm a victim of that, but I can choose the leverage. And so by looking at these different possibilities, when I have a financial investment that I'm thinking of leveraging using debt, I can decide on what the impact of using these different amounts of debt leverage are and what it will do. Now you'll notice that when I use lots of leverage, let's say 80% debt leverage, if interest rates are low, like 2%, my return on equity gets to be spectacularly high, 25% in this case. However, if I don't use any leverage at all, it's down here at a very modest 6%. And those of you who are mathematically inclined might be able to work out why there's 6% there, and you also might be able to see why 6% doesn't change when I don't borrow any money. Because regardless of what the interest rate is, if I haven't borrowed any money, it's not going to have any effect on my investment. However, as the interest rate changes, in this case it's increasing, if I do say, well, I'll use 80% leverage because that gives me the highest return on equity, what I find is that as the interest rates increase, my return on equity falls, and it falls fairly spectacularly down. In this case, if interest rates were to get up to 20%, I'd end up with a loss per year of 18%, which is pretty nasty. And so the nice thing about leverage is that it helps me in the good times when interest rates are low, but it really cuts into my profitability when interest rates are high. If I'm a bit more modest, I'll find that here at 40% leverage, I've got a modest benefit from leverage at low interest rates, and that then falls to the point where I'm still making a profit, but not very much profit if interest rates gets very high. Now we might say that's all fine because interest rates are never likely to get to 20%. Guess what? In living memory, they were up at 20%. And there are still a lot of people, myself included, who were in the investment world at the time when borrowing money would cost you around that sort of interest rate. So that may come again, and it's something that you need to be a bit wary of. So you can see this is a fantastically powerful tool. The next task in Excel, which I'm not going to demonstrate, is how to take that table of values and then present it graphically. And here we have a demonstration of it shown, but you can do that yourself. Likewise, the remaining tasks I'm also not going to demonstrate here. You'll be able to work those out by applying the financial mathematics, which is described in the brown, and then filling across, and you should be able to get rid of those yellow highlights. You don't have to do those for the next couple of weeks, and in fact we've got some other demonstrations which do very similar, and so you probably don't really need to do tasks 4 and following yourself. However, they're good practice. For those of you who are inclined, there are also some extension activities. You notice this little box here. It says extension activities, practice charting the tables from task 2A. And there's other extension activities in this exercise. Overall, the FinTute exercise is a really nice way of toning up your Excel skills. Now, getting rid of those yellow highlights is always a bit of a delight. There's the core activities, which is the tasks 1, 2, and 3. You can do these other activities, which I say you will find more extension activities, and you've got extension activities on the extension activities for people who really want to do extremely well in mastering property investment and analysis computation. After you get that, where you can congratulate yourself, all done. If you've got all that stuff under your belt, basically nothing in the rest of the course should cause you a great deal of drama, at least as far as calculating the financial maths and using the Excel skills.